Hi everybody. Today we're going to start doing our reflections and line symmetry chapter. You guys did a bit of a start on this previous day. We're going to do our formal notes on this today. So most of this I think is a review for you guys, but a couple things aren't, and we're kind of going to put a couple concepts together that you probably haven't put together yet. So a line of symmetry is a line that splits an object or shape into two mirrored halves, like you can see here, here. To check if an object has a line of symmetry, you can draw a line through its center, and then rotate it 360 degrees. This is maybe easier to show an example of. So if we've got a circle like this, we're going to identify the center of it, which is right here, and we'll draw a line that goes right through that center. And if we then rotate this line, we can see that no matter where we rotate it, it splits it into two different halves. And that means that this circle actually has, since we can rotate it anywhere, it actually has infinite lines of symmetry, which is a unique concept or a unique property of circles. But if, for example, you took this butterfly and say you decided that was the center there and you drew a line through it, you'd only get this one line of symmetry, no matter where you rotated that line. So many objects have more than one line of symmetry, although many don't, right? We talked about bilateral symmetry before for a lot of animals. So a line of reflection is kind of like a line of symmetry, except it is not a single object. Okay, it is it's drawn halfway in between an object and a duplicate mirrored version of that object. So a really solid definition that is from this site I'm about to show you is a transformation where each point in a shape appears at an equal distance on the opposite side of a given line, the line of reflection. What they're saying there, to I guess break it down a bit, is you draw a line, and if there's a shape on the left of that line, over the line of reflection that you draw, it means there's a shape on the right. And every point that's labeled is the same distance away from one another. So if we follow that that link there, and you guys feel free to follow it, it will take you to this website. So the idea here is you can make any triangle. Let's put A over here. We'll put B up at the top, and we'll put C right there. And then this blue line is our line of reflection, so I can move it really close to our original, and then our points get very close together. I can move it far away from our original. Our points get further away. So if we say this is our line of reflection, then by our definition, A is going to be a certain distance away from A on our reflection. And B will be a similar distance away to that line of reflection. So let's say A is 10 centimeters away, then our reflection here would be 10 centimeters away from the line of reflection. Say point B is 15 centimeters away, well, then point B on our reflection is 15 centimeters away from our line of reflection. And if C is 25 from the line of reflection, then C on our reflection would be 25 centimeters from our line of reflection. So they're equivalent distances apart from this line of reflection. Play around with this if you want. This site is a really good way to get an intuitive grasp of what a line of reflection is, which might make it easier to do some of the questions you have to do. All right. Excuse me. So we need to go back over the Cartesian plane. Many questions about lines of reflection deal with the Cartesian plane. Same with the lines of symmetry. You might be given like half of a shape. And if you remember, I hope you do, this is the thing that has a big X and Y axis. There's a grid pattern behind it. The X-axis is horizontal and the Y-axis is vertical, always. Let's see if I can pull this up for you guys. Oh no, we'll just use the examples here. So we've got our y-axis here, that green one. Our x-axis is that blue one. The way I like to remember this is the y is a taller letter than x is, which means that it's the tall one. But if you have your own way of remembering, that's cool too. On the x-axis, right is positive. So this direction here is positive. This direction here is negative. Generally, that'll be shown along the scale. On the y-axis, up is positive, down is negative. And I don't know if you guys did the quadrants, but I thought I'd bring them up. So quadrant 1 is when both x and y are positive. So it's that top right quadrant. Quadrant 2, you've got x being negative, but y being positive. Quadrant 3, they're both negative. And quadrant 4, x is positive, but y is negative. These are usually numbered with Roman numerals, not all the time. But the way I remember it is quadrant 1 starts up here where everything's positive, and then it goes counterclockwise. That's more for future reference. I don't think it'll be necessary for this unit. And I didn't know if you guys did it, so I thought I'd teach it to you. Okay, ordered pairs are coordinates on the Cartesian plane. They're written like this: 2, -3, all in parentheses. The first number is the x-coordinate, so that 2 is the x-coordinate. And the second number is the y-coordinate, so the -3 is a y-coordinate. So if we were to actually plot that, we would have x being 2, so we'd go to here, and y being -3, so we'd go down. 1, 2, 3. So we'd be right there. Would be our coordinate that we made here, 2, -3. So you notice all these are written same way. First one being the x, second one being the y. So let's do a couple examples on a Cartesian plane. And after this, I'll let you guys walk through the textbook examples on page, I think it's 354, 357. On your own. And I want you guys to work through those using graph paper, because there's, especially the example number 2, is really, really good. It's a type of question that you might not be expecting, but it gave me a moment of pause. So I think I want you guys to check that one out. Let's see here. Which layer should we use? Let's get rid of this. Here's our Cartesian plane. Okay. So on our Cartesian plane, let me just select our drawing tool here. The easiest way to start, right, is you plot a point. So let's say our first point is, oh, I'm on the wrong one. Let's say our first point is 2, 2. That's point A. We need to make sure we know where to plot this first. So we go x being 2 right here, and y being 2 right here. So there's our first point. And let's say point B is, let's say 2 and 5. So we go to 2, and we go up 5 right here. Point C is 3, 4. So go to 3, go up to 4, and this is going to be our triangle. Pretend those are straight lines. So there's our triangle. There's a couple questions that you might be asked about this. One of them is, this triangle is part of a larger shape along the dotted line. And we'll say this is the dotted line. And they might say, draw the rest of the shape. And this line is a line of symmetry. So then you would have to say, okay, well, I know that this point sticking out on the right side goes one down and one over from this top point. So we would go one down and then one over in the opposite direction. And then you could draw your new shape, or the new half of the shape, I suppose, like that. So that's taking like a polygon and saying this polygon that you're given is part of a larger shape. You might have a more complex polygon that goes something like this. And in these questions, they'll always tell you which line you're supposed to be, or which line is a given line of reflection. So maybe it'll be easier if we use a different color here. So let's say this is our line of reflection on this one. And they'll say draw the entire shape, or the missing half of the shape. So let's start with this point here. We know that our next point that we're going to draw is one up and one over. But since we're doing a reflection here, or a line of symmetry, we're going to go one down and one over. And instead of two away from our original point, or two up from our original point, we'll go two down from our original point. And then we go two to the right. This one we go down two, or in this case, up two, and back to this one. So one of the nice things is, if you do all of your points correctly, your last one you shouldn't have to draw because it'll just connect again. But if you do find there's a mistake there, it means that you've probably messed up one of the other points if it starts looking funky. And if it looks symmetrical, like this one does, then it probably is correct. It's pretty easy to see when something's out of whack. You'll look at it and think it's weird. So another question, let's erase all of this. Another question you guys will see is one that actually asks you to do lines of reflection, or gives you a line of reflection that you have to work with. So that'll look something like this. Let's do another triangle. Actually, we can just use the same triangle example. That'll make sense. So A is 2, 2. B is 2, 5. And C is 3, 4. Cool. So they might give you a line of reflection. We'll use a different color for this one too. They might give you a line of reflection saying, use the y-axis as a line of reflection. So right down here. When you do a line of reflection over the y-axis, they might not mark it. Okay, they might just tell you the y-axis. But it always helps when you're doing reflections to actually label your points. So we'll say A, and we'll say B, and C. Okay. And actually, this might be something you guys want to do, is do it in two colors, so you can tell which one is the original and which one is the actual reflection. So we'll keep this one all in one color. So let's go and reflect our point A. Point A is 2 away from our y-axis. So we're going to go 1, 2. That's our point A. Point B is also 2 away from our y-axis. Note that I'm keeping the value of the y portion the same. I'm not changing it because it's just being flipped over the y-axis. So the y values of all these points are actually going to stay the same, and then the x values are going to get to basically turn into negatives. And we'll take a look at the C. It is 1, 2, 3 away. 1, 2, 3 away. Oh, I miscounted. Excuse me. 1, 2, 3. That's a good example, though. If I drew my triangle like this looks different than this does. So immediately I'm going to go, okay, something's wrong here. And I'm going to notice that this guy is a little too far out. So we should make it a little tighter in. I'll recount. We go 1, 2, 3. And that looks quite a bit better. Although my drawing makes it look not the same, the points are the same, which is what's important. So we have A, B, and C. So that's a line of reflection there. If we decide to do a line of reflection over the x-axis here, we would do a similar process, but this time we're going to count from the x-axis. So A is 2 away from the x-axis. So now this is A. B is 5 away. C is 4 away. 4. We would get something looking like that. And this is one area that some people get kind of tricked by, and they mislabel their new shape when you flip it over the x-axis. So those A's are closest. The A becomes the top in the reflection, where it's the bottom in the normal one. So just be careful for that. And then the last example I want to show you guys is if you're given a line of reflection that isn't an axis, sometimes it could get a little different. So let's do some new coordinates just to practice a little more. Oops. Okay, so we'll do triangle DEF. Triangle? No, let's do something different. Let's do, let's see. Oh, my brush stopped working. What's going on here? Okay, there we go. So let's do something like this. We'll draw this, this. We'll do a polygon here. So we've got A right here, and A is 2, 5. We've got B over here, which is 3, 6. Got C right there, which is 5, 4. Whoa. And we've got point D down here, which is 3, 4. Oops. And keep in mind, guys, some of these questions will require you to basically plot your ordered pairs. So that's why I'm doing it for all these questions. Not all of them require you to use ordered pairs, but some of them do. So be aware that you might be tested or assessed on that kind of thing. So let's do a line of reflection on right here. Let's say that we were given that as our line of reflection. So although it's not one of the axes, so it won't look super pretty, the way we do this is the exact same. So we take a look. I usually start with the dot closest. So I'm going to start with D. So D is the closest to the line of reflection. In my mind, I guess C is equivalent, but I'm going to start with D. It's arbitrary. And it's 2 away. So we go 1, 2. So we're actually going to have this reflection touching the axis. And C we'll do next. And A is 1, 2, 3 away. So we go 1, 2, 3 away. and B is, and in my head, instead of counting it towards the line of reflection, I would just do this diagonal line, but I would do it in a reflected direction. So we would get something like this. Whoa. Okay, that line is not good enough, I think. Let's try that again. Shoot, this doesn't want to do it. Okay. So we'll double check. We've got C being 1, 2 away, so we're good there. We've got D being 2 away, we're good there. What about B? We've got it being 4 away, so we've got 1, 2, 3, 4 away. Then we've got A being 1, 2, 3 away, which checks out. So these are our new points. We can label them. Our reflection of A, reflection of D, reflection of C, and reflection of B. And that's it. That's all there is to it. So after you're done watching this, or I suppose right now if you want, go check out the examples on 354 to 357. Pay special attention to example 2, I believe. Yeah, example 2 and example 3. Because those are reflections, those are the things I think you guys will have a little bit more trouble with. I think most of you understand the idea of a line of symmetry. And that's it for this video. Cheers, guys.